Okay, let's start. So, good morning everybody to the first VMware Code session. I guess we will hear a lot about Kubernetes in my session also. My name is Tom Schwaller. I was working as a technical product manager in the BU, but I was a Linux architect, NSX SE, Cloud Native SE, did a lot of things. And my main focus is right now Project Pacific, Enterprise PKS, tons of mission control, all this cool new stuff. Who of you actually already is using Kubernetes? Yeah, I was expecting that. So it's a very basic talk, but to make it a little bit more interesting, actually we'll show something probably never have done at the VM world. The way I do the demos, you will see that later on. My agenda is pretty short and the time is pretty short also, so I have to speed up quite a lot. I took over this session from my colleague in the US, and honestly I would have used 1 hour, not just for 25 minutes. So I will deploy an application just using kubectl, the normal mechanism, let's say, for Kubernetes. Then look at how you do the same thing with Helm charts, which is basically templating all your YAML files you use to deploy the applications. And the last part is about deploying application with operators. I'm not sure I will reach that part. My colleague actually didn't show that. We'll see if I can make it in the 25 minutes. Tomorrow there's actually another talk from me and Michael Gush about how you write operators with Python, and we show you how to write a VM operator, something you will see as a product in Project Pacific, so you can use the Kubernetes API to create virtual machines. We'll do kind of a poor man's implementation with Python, which is actually very interesting to see. So, as I said, the 3 methods, I mean, I'm not going to start about Kubernetes, right? You heard it all the place, you know that. The good thing is it's an architecture actually to build platforms. It's not just one thing. And you have this API endpoint, which is normally load balanced, for example, NSXT load balancer, and you talk to that endpoint, and kubectl actually is doing that for you. You give it a YAML file to create resources, which can be whatever you want. I mean, a deployment, a replica set, persistent volume, a secret, whatever. There are tons and tons of resources there, and you send this YAML file, and the API server saves that, and you have a desired state, and the controllers actually make sure that the desired state is being realized. And as you have seen with Kubernetes, we are just starting. Putting that into the vSphere platform will actually allow you to have resources which are vSphere resources. And we will create Kubernetes classes, we create pods and things like that. And kubectl is just a binary to talk to this API server. The next one, Helm, as I said, is the same thing, but it's using Go templates. So it's and it's very easy to use actually. The operators is really the next steps, because all of these deployment mechanisms do not operate what you have run or deployed, right? I mean, maybe you deploy a database and you want to do a backup, or you want to do an upgrade, things like that. And the operators actually is doing that with the same mechanism, but also having special resources. So you extend your Kubernetes API with custom resource definitions, and the controller will actually make sure that these resources are deployed. And the example I'm going to show you, hopefully, is how you do that with a MySQL database. So you get a new resource, MySQL database or MySQL cluster, which the operator will actually deploy for you. So these 3 setups are what I'm going to do here. Enterprise PKS, very short. It's a product now out for almost 2 years. It's using Bosch to deploy the virtual machines. It's using NSXT below it. We have the harbor registry integrated, and it's actually one command to create a cluster. PKS, create cluster, a new name, and you have it. The next generation, or so to say the evolution to that, is using a cluster API, which Project Pacific will then do that. So you have actually a vSphere API, which is Kubernetes, right? You can create a cluster, you can create a virtual machines, things like that. But there's a lot of work in that product, and the NSXT integration is actually very evolved, right? It will take some time to get there with another architecture. So let's go to the first demo. Very simple, it's just deploying an application, in my case WordPress, using kube control. And as I said, since I just don't want to repeat the session from the US, I'm using so-called Jupyter notebooks. If you maybe heard a little bit about machine learning or deep learning, almost every data scientist is using Jupyter notebooks. It's basically a website which is active, so you can execute command, you get visualizations and things like that. The challenge I had, and by the way, on GitHub you will find more than 1 million notebooks. So I don't know a data scientist which is not using notebooks. Even if you go to Azure Cloud, Google Cloud, you will actually get notebooks to do their stuff. And I'm using that to actually do my demo with Kubernetes. And I'm executing bash commands, and maybe sometime later I will also execute Python scripts inside the same sheet, so I can actually visualize things. I can do a MySQL command and do some graphics, things like that. And the challenge I had, because you can only run so-called one kernel inside the notebook. So I can do either bash script, or I can do whatever, Python or Go or Ruby or whatever, but I cannot mix them. And that's something I didn't like. I wanted to have bash and Python in the same script. And I found actually a kernel which is called the SOS kernel, scripts of scripts, which allows me to, you see, execute different kernels in the same. I still have a little bit, yeah, it's better now, in the same kernel. And as you know, many people do these demos using maybe demo magic. You heard about that. It's a shell script which is wrapping your own shell scripts. But I want to do demo as code here. So actually you could take this thing here, this sheet, and execute it in your environment, assuming I have done it right. I mean, there are a few tricks here which will not make it as simple as that. But you see now, I can execute all these commands in this website. Of course, the login into my... That's funny, that's the first time it actually happened. But anyway, let's... I tested that at least 20 times. Anyway, maybe I changed something here. No, it looks good. But you see, I have a PKS cluster. Let's just get the credentials of that cluster. Take some time, because actually it's executing the command in the background, and then the kernel is giving me back the result. And you see, I don't have to type anything, but I still can give you that. So it's not just executing a script, whatever, you can put everything in here. So, okay, let's see how many nodes I have. You see I have 4 nodes, and I have some of the namespaces. One is VMware System TMC, which stands for Mission Control. So actually this cluster is also managed by the cloud. Let's now go to my first demo. And you see here I have my WordPress, my Helm, and my operators demo. And the first thing you have to do with Enterprise PKS, it's something many people forget, is actually to create a storage class. I remember that in a customer POC, in front of the customer, Helm install, what I will just do in a minute. Nothing worked. I just forgot to create a storage class. So let's see if I have a storage class. Okay, it's there because I already created it, but in case I wouldn't have done that, I can just use this definition. You see, I'm creating a storage class, and very important, I put this annotation default true. So if I will create a persistent volume and actually consume that in a pod, I will have this default storage class which will be there, so it will always work, because many Helm charts actually need a storage class and are configured like that. Okay, let's deploy that. Okay, that's already, it's unchanged because I already have done that. Okay, I have this YAML files in there, and you see I have 3 things. I have a secret for my database, I have the MySQL database which is using that secret, and I have WordPress which is running on top of as a PHP application talking to the MySQL database. You see, there's nothing fancy here. The secret is defined as everything in Kubernetes. we can define it as a resource. It's called kind, and in this case it's kind secret. Okay, the deployment for MySQL is a little bit more complicated. Maybe the most important one is you have these volumes here. So actually I create some persistent volume and the database will actually use that. Why I'm doing that? Because your database, when you delete the pod, you want to have your storage still there in Kubernetes, right? If maybe the MySQL is crashing or it's being recreated, or you want the storage there, and the persistent storage is making sure of that. WordPress, yeah, a little bit more. You see it's called WordPress. I have some port which are exported. I have this persistent volume claim actually, which is now consuming that volume. And I have a so-called deployment, which is called WordPress. And here's the important thing. I have an image, WordPress, Apache, which is now being deployed. So MySQL, the database, and the secret. And all this stuff I'm now going to deploy. Basically, just the folder with all the YAML files in there. And you see the WordPress MySQL is created, the volume is created, the deployment, the service, which is a load balancer in front of my WordPress instance. In my case, I just have maybe just one, but if I scale it up, the load balancer is then taking care of load balancing all of them. Yeah, and you see, I can still add commands here. For example, get pods. And see, it's still running. Yeah, as my time is pretty short, let's see if it's still creating them. Maybe I come back. Because it has to download the image, of course, right? It's downloading that from the internet, and in my environment, this can take some time, but maybe it's still doing it. So let's go forward. Don't want to use my time here, but before I go forward, I will then delete this deployment. So this was the first way of doing things, but you see, writing these YAML files, I mean, that's pretty complicated. If you do it the first time, you normally maybe copy some things, change a few things. There's a lot of things you have to learn there. With Helm, it's basically a templated version of that. It's a package manager for Kubernetes. If you know Linux, you probably know Yum or apt or Zipper, or maybe Homebrew or Chocolatey if you use, let's say, a package manager on your macOS or on your Windows system, or if you install Python packages with pip or npm for Node.js. So it's just a package manager. Has been created by Days, Bitnami was involved there, and also Google. And the important thing is it's using the Go template language. To create a Helm chart is actually pretty simple. You just say Helm create a directory name and copy your YAML files into a folder inside this directory. It's a certain subdirectory. And actually you already have a Helm chart. Of course, it's not doing much because it's not using any templates, right? It's just deploying what you have. But that's how you can start. And some wording, you have these charts, so-called Helm charts. And you see here that in the templates file, you have, for example, a service, you have a persistent volume claim, a deployment, and some tests also. And very important, the values allows you to change the properties in your template. You can also do that on a command line, like set, I would like to change the name, I would like to change whatever, right? But normally you just use a values file and do that also with the YAML file. The repository, there can be many of them. There is a standard one from Kubernetes, but I will actually add one from Bitnami for my demo. And you have certain releases of your Helm chart. We'll see that also in a second. So if you just say Helm install something, it will always take the latest release, but you can say, give me just the release 1.0, right? And then you can search for releases and you see, oh, there's an update from 1.0 to 1.1, and you can just use Helm update to the new release, and Helm will all handle that for you. That's how it works. Very similar with the Helm install. Right now we are still on Helm 2, which is using this tiller pod. And this tiller pod has a lot of, can do a lot of things actually. It's basically admin in the cluster. And to secure that, there are how-tos how to do that, but for many demos you see people actually deploying that in a very unsecure manner. Helm 3 will get rid of this tiller. There's no tiller anymore. You just do a Helm install versus the API. And there are also a lot of other changes, but I'm still using Helm 2 here with the tiller. So to install Helm, I mean, everything is in here. You can just read that, but I will not execute that. I will just go to the demo. And you see here in the kube system namespace, I have this tiller pod which is running, which means I can now talk with the Helm CLI to this tiller, and this will do the work for me. As I said, I will just use the I will add the Bitnami repo. You see it has been added, and now I have you see a lot. I also have Jupyter Hub, I have Bitnami. Press Labs is actually a demo for the MySQL operator, and now I can actually install just let's say Bitnami WordPress, which is a packaged version of WordPress in version 7.1, and I give it the name WordPress Bitnami. That's what I do now. Technically speaking, it's getting the YAML files from the internet, it's deploying all of this stuff, and it actually gives you a little bit of a how to access it. I mean, it's creating a password, so I can get it from a secret in Kubernetes, and also get the load balance IP address. See that in a second. So Helm shows me, okay, Bitnami WordPress is deployed, and I can look at the status. It's good there. And as you see, I'm executing all these commands in this web interface, right? I think that's a cool thing. Right now you would say, well, I mean, I can do it on the shell. Of course I can, but all the commands I typed, or the whole workflow, you actually see it here. You can extend it on your own, and when I will add more, let's say, visualizations, then it will become really cool, because that's something which is probably harder to do. I can do a rotating stuff, you can zoom in, all this fancy stuff I can actually do here, because I have the Python and the Bash kernel running in there. So let's see if I have an IP address. So you see it's 10.40.14.44. I'm not sure it's up yet. As I said, it takes a little bit too long here. Probably it's still loading, so I mean I have to live with that. But let's see the secret which was created. So you see that's actually my admin secret, which was created let's say by the installation routine. And now, okay, assume it's running, right? I mean, I don't have time to wait until it's running here. Let's see if there are other versions. I can do a search, and if I do a search -L, not just search Bitnami WordPress or just WordPress, maybe you just want to have the Kubernetes kind of WordPress and not the Bitnami one, you will just get the latest version. But with -L, you see all the versions here. You see, and there are actually many of them. Bitnami is maintaining that since many years. And if I want to do an update, I cannot now just say Helm upgrade WordPress Bitnami. That's the name I gave to this deployment. Bitnami WordPress is the Helm chart, and I give it the version not 7.4.0, but 7.4.1. Okay, that takes some time. And now actually it's upgrading, it's recreating the pods in the new version. I can also go back, and if I do a Helm else, you see, oh, I'm on revision 2 now. I went from version 1, which was 7.4.0 to 7.4.1, and I can go back if I want. Okay, I will not wait, because as I said, my time is pretty short here. So I just delete this thing. But I will show you actually how my colleague did in the US, because the demo he did was very different. He created, he had the Helm chart actually locally, right? I mean, he downloaded it, and then he did create my WordPress. He removed the templates directory and the test directory, and just copied his Helm YAML files I used in the first demo to this my templates directory. And what he did then is to just change something in there, right? It's not a Helm chart technically yet with templates, but he just changed a property, the version of the image. And he then did the same thing I did with an upgrade, but locally with these new files, and Helm was just updating his environment. But I thought it would be much cleaner to actually do it the way you normally do it, right? I mean, creating or using Helm charts which are versioned and not doing it manually like that. Yeah, so let's go further. I just have a few minutes left. So the operators, as I said, consist of two pieces. It's the resources you create in Kubernetes, the so-called custom resource definitions, which can be whatever. It can be a VM, it can be a MySQL cluster, Redis cluster, it can be maybe even a physical hardware you try to Kubernetize, right? You could say, oh, I'm managing this hardware, do a firmware upgrade for me. I mean, nobody has done that, but you technically could do that. You run a Kubernetes cluster to do firmware upgrades of hardware. I mean, the sky's the limit there. So the operators were really designed to, let's say, manage more complex applications. It's not just a simple thing, it's very complex stuff. And you extend it with these custom resource definitions and the controllers, which are just, let's say, looking, oh, there's a new resource being created, I have to do something, right? I mean, the whole mechanism in Kubernetes is pretty complicated, but it's just little pieces. It's not one big thing which is controlling everything. You have all these controllers managing their own stuff. That's why you can make it pretty scalable. So what you do, normally you have to install this operator. And honestly, the best way to do that is to use a Helm chart. So you just do Helm, install my operator, and then you can use just Kubernetes, kubectl with the YAML files, create a cluster for me, things like that. So let's go back to the demo just to give you an impression of that. So in my case, I had a new repo, which is from Press Labs, a company I didn't know actually before that. And I just installed you see the Press Lab MySQL operator. Actually, in my demo, I also have a Redis database, but in my cluster, it was just too small. I mean, the Redis cluster needed too much resource I could actually not deploy. That's why I changed that. So now I have an operator, which means I have custom resources and the controller, which allows me to create MySQL databases. And the way you do it, I mean, it's a very simple example, but you see it here. I have a new kind, MySQL cluster. Of course, replica 1 is just because I don't really have that much resources here. I could change that to 3 or to start with 1 and then see, oh, the class is actually getting overloaded. I can just update that to the number 3, and then the operator will actually make sure that this class is updated. In the operator, there's a lot of knowledge you normally have as an operator, right? I mean, how do you do an update, how you do add a new node, how you cluster them, how you do the backups. This is all, so to say, in this custom resource plus the controller. And okay, I create one here. Has been created, and I guess it will take some time until it's really, it's still crashing here, so it's trying to install it. I don't have that much resources here. So yeah, time is actually over. I could manage to do more demos than my colleague in the US, but I hope it was not too fast. Just to repeat, so I showed 3 ways to deploy applications, just using kubectl, using YAML files, using Helm charts, which are templated YAML files, or using an operator which is, I mean, becoming the de facto standard of doing things. By the way, on Project Pacific, you will see there's an operator for VMs. There's a VM operator. There's an operator for whatever, and you will see more of these things coming along. So this was the last thing. Just one simple example, MySQL cluster or Redis cluster. And yeah, I think that's all. Maybe you have one question. Time is up. I would have reserved 1 hour for this talk personally, but I didn't have a choice. Rushing through that in 25 minutes is pretty challenging. So yeah, thanks for your time.